So page 98.
Number 25.
25?
Uh-huh.
So this says take Q equals C plus D over 2 and solve that for D.
Mm-hmm.
And these are the ones we just barely got into last time about people have a hard enough time already with solving equations, and all of a sudden we throw you stuff without any numbers in it at all. But they both have exactly the same procedure. Whenever I have an equation where I have a fraction in my way, I have an equation, so what am I allowed to do? What's the worst part about this?
Backwards.
Besides there's all the letters.
It's backwards.
True, it's not by D by itself yet, and there's letters and stuff in the way, but what's really the worst part about what I have to do something with? The fraction, yeah. So how do I kill that fraction? Yeah, multiply both sides by 2. So on this side I get 2Q. The 2's went away there, so I get just C plus D. Yeah, and then how do I get D by itself? Yeah, you just say to yourself, what do I want to get rid of? The C, it's adding right now, so I subtract it. It's positive, so I subtract it to make it go away. What is 2Q minus C? I love it, 2Q minus C. Well, I don't have a clue what the hell it is, so I just got to write the whole thing out. Until somebody tells me what Q and C are, I can't do that. So I just have to leave the whole thing undone.
So it goes the same thing for number 30 as well? It's the fraction.
Same idea. Yeah, in fact, that's a nice one. That's just one step away. Yeah.
So it would still be the same thing if we don't have a number at the bottom?
Yeah, exactly. If this would have been Q equals C plus D over M, the first step would have still been multiply by that thing that's on the bottom and then subtract C. Would have still been the same exact steps. So on one level, it's kind of like you look at the problem and there's no numbers. So numbers are sort of like what we latch on to. We're like, we know 2 and 3 and 4. So when you're solving an equation and you're learning how to solve an equation, let me see here. If this would have been if it would have been like this and I said solve for D, that's just a little bit better. Because at least there's just that one letter. There's just one letter in that thing, right? So there's no question about one trying to get by itself. There's just one letter. It must be that dude. But I would follow the exact same steps. The only difference is I don't know what the hell 2Q is. But over here, 2 times 10 is 20. I can actually do the operations, right? That's the only real difference, is that I can actually do the operations.
I just had like the kind of the same question on 52, but
Oh yeah, this is even better. Any questions on this guy here? So really, yeah.
What if it's minus instead of positive? Would it be any different as far as you subtracting the C again?
If this would have been C minus D, is that the question?
Yes.
All right, so is everybody cool with that? So if this would have been C minus D, there would have been a bit of a difference. Not a major one. The next step would still be subtract C. But then I have one last step, because I don't have D by itself yet. And a lot of you guys, when you kill this guy, this goes away somewhere. I'm not sure where it goes, but that's still there. It's still a negative D. I just really have one last step. Yeah, divide by negative 1. That goes away. So the cool thing here is, actually I could just change both of these signs. Positive 2Q divided by negative 1 is negative 2Q. Negative C divided by negative 1 is plus C. So that if that was a minus there, it had that extra last step. Because when I do this step, I don't have D by itself yet. Whereas before I did, because the last problem, it was positive. It was by itself. Okay, maybe.
I get it.
Big difference.
Yeah. Well, and honestly, it's just one more step. is the big difference. But it does make the answer look different. What was the other one? 52? 52 says that. Does that pi r square look familiar? Yeah. Yeah, that's the area of a circle, right? So this is the angle measure of a piece of pi, right? And here they really just want me to solve for r squared. Now, when people see this, you focus on all this stuff. I don't care about any of this other crap. All I care about is the fact that here's my r squared. That's the thing I want to solve for. What's wrong with it currently? What makes it really difficult to solve for it? Where is it? It's on the bottom. Anytime the thing I'm trying to solve for is on the bottom, I'm going to immediately multiply it up. Because if it's on the bottom, I can't do a damn thing with it. I need it up so I can get it by itself. So the very first thing I'm going to do here is multiply by r squared. Get that thing up. So it cancels over there. And now it's like up on the top here. I can do stuff. And now it's one step away from having r squared by itself. What do I need to get rid of?
Quick question, the pi doesn't have to stay with the r squared?
Oh, sorry. There's the pi down there too. Thank you. But it doesn't have to stay with r squared. It's just still down there. Yeah, I only cancel the r squared. The pi is still down there. What's the last step here? Yeah, divide by s. So here's the funky thing. If I divide this side by s, I really don't want to divide this. Oh, that looks disgusting. Can somebody help me out? What's division by s? It's the same thing as multiplication by 1 over s. So if I divide by s, I have to divide the other side by s. And notice something funky. This is kind of a cool thing to realize. At the end here we get, the s's go away, I get r squared equals 360a over pi s. Look what fundamental, here's the original problem. What happened with these two things? After all this crap, they just switched places. Now that is that's like one of the most fundamental important things to realize from algebra that will help you out in like a science class. That very fundamental aspect of algebra will help. Here's why that works. What's 10 divided by 5? 2. So what's 10 divided by 2? 5. Alright, so that's why it works. So if I want this piece by itself, I can just switch these two around. And really, if you want to see the steps, you multiply both sides so to get that thing you want by itself out of the bottom, and then you divide by the thing that's already over there. So that's why I multiply this guy up, I divide this guy down. They do end up just switching places. That's a really cool shortcut to realize. Now, if you don't realize that shortcut, it's okay. You can still multiply your guy up and then divide the stuff you don't want back down. So let's take a step back. That's a bit more advanced of a kind of problem we're talking about in this section. If I have something like this here, and I want to solve for W. All right, so just hold on a second if you know what to do next. You do the exact same steps you would if there were numbers in there with a W. So if I notice how this problem here is actually just about the same problem. Those two are the same problem. If A was 7 and B was 3 and C was 10, they're the same problem. This is a specific example of that problem. Are you guys semi with me? Do you have to do this as part of this problem? No. This is me teaching why this works the way it does. What's the first step you do here? Subtract the 7, because here's where your unknown is. You get that thing by itself first. So here's where your unknown is, the W. You want to get it by itself first. So what do you want to do? Subtract A exactly the same way you would subtract 7 there. So now you got your WB. Good. C minus A and C minus A. Over here, the only real difference is I can do 10 minus 7. So what's your last step there to get W? Yeah, divide it by the thing you don't want. So W equals this mess. So here, divide by 3. Now watch this. Now again, all you've got to do for this kind of problem is this. This is me showing why it works the way it does, because we should be a little more comfortable with this than we are with that. Now go one extra step with me. This is one extra step. Right? This is already extra. A here was 7, right? B here was 3. And C was 10. And we got 1 for W at the end. So here, if I plug in C is 10, A is 7, B is 3, I should not be surprised that I still, of course, get 1. I just reorganized things. So what was it easier? Once I solved this is a lot easier to plug and get, because the answer just pops right out, than this would be. So that's why it's important to be able to manipulate formulas with just letters in them, so that you get a better formula for a situation. If I know a bunch of C's, A's, and B's, I don't want to have to solve every damn time. I want to solve once and then plug my stuff in. W pops right out. That's the importance of being able to do this. Yeah.
There's one similar to that in the book. Could you do it? It's number 35 on page 98.
Oh yeah, so that's kind of like an in-between dude, right? Yeah. He's got one more letter than we're used to, but there's still some numbers popping around. Let me see. Try to stick here. You guys got this business here? No. Where are we at?
Oh, no, we were just curious about number 45, but you could do...
Oh, wait, we'll get there. So number, what was it now? 35. Some of you guys might see, I'll make the semicolon looks pretty. Some of you guys might know where this is headed. When we start doing graphing, getting y by itself is important. So right here, they're just trying to get us ready for that. So again, the letter that I want is here. So I want to get that piece by itself first. Anything else with it, I want to get rid of. So I want to subtract 2x first. So the 5y is still there. 10 minus 2x is 10 minus 2x. Yeah, now the only thing keeping my y from being alone is a 5. It's multiplying, so you could do this. This is perfectly fine.
You can't do nothing to it, right? Because you got a variable on the top. So 5.
You can do one thing, and it's not even that big of a thing. You can split it up.
Alright.
So you can stop here. That's fine for right now. Some of you guys might realize that this next step is important for later. Well, let me take a step back. And please, trust me, let me say this. If I am ever doing something that makes little or no sense, you must tell me. You must ask questions, right? Because if it doesn't make sense to you, it probably doesn't make sense to about 12 other people. They're just not saying anything. So be their hero. Say something. Because I see a lot of you guys with a certain face that tells me something. Is everybody cool with these first couple steps here? Okay. Yes?
I don't think I would have just thought it was okay to take the 2x from the 10.
Gotcha. It's not.
I mean, I get that we didn't actually do the math at the end anyway, but...
But it's sort of like, why is it okay to add 2x and 5y? So it was a choice they made, really. They could have said 2x plus 5y is 10, or they could have said 5y is 10 minus 2x. They both mean the same thing, right?
Oh.
If two numbers add to be 10, then 10 minus one of them is the other one. They both mean the same thing. It's just a way to reorganize it. So I'm trying to put this...
So just since it's not like terms you don't actually do
Exactly. But the math doesn't care. Math does not care if it's like terms, if it's known, if it's unknown. Solving equations says if you subtract from one side, you better subtract from the other. It doesn't say a damn thing about Well, if you're able to put them, no, it doesn't care. I go, oh, I'm not able to put those together, so let me just write them both there.
Okay.
Is that cool? So there's always, my Math 88 guys know this, I say this a lot. There's always a process in mathematics that does not care what's in it. There's a process of solving equations. It doesn't care if you got y's, 3's, 4.8, w, it doesn't care. It says whatever you do on one side, you do the other side. That's why I'm allowed to do that. It's not like terms, though. So I don't want to see an 8x here. That's neat. You got to keep it separate because I don't know what the hell it is. Yeah.
I'm sorry. Number 45?
Real quick. They have a question on 45.
Oh, sorry.
Let me finish this out real quick. So either one of these would be 5. Because what's being divided by 5? 10 and negative 2x. So you could explicitly divide each of them by 5. Either one of these is fine. Some of you guys might realize that this is a little bit better for graphing lines. That's coming in chapter 3. Right now, if you stop there, I'm happy.
The answer in the back of the book is different.
I hate that. What do they say?
They say it's y equals negative 2 over 5x plus 2.
All right, that's that.
So it's the same thing.
Oh, yeah. Because I could do 2 minus 2 fifths x, or I could do negative 2 fifths x plus 2. Now, this is getting more towards mx plus b, if that makes any sense to somebody. If that doesn't make sense to you, it's okay. We're not to chapter 3 yet. But they're kind of looking ahead. There's no reason to look there yet, really. This way or that way or that way. Any of those is the same. It's fine.
Where does the 2 come from?
10 divided by 5.
Oh.
Cool. The mistake people make is they do this. When they have this, they do that. And what mistake did I just make? Yeah, how did that guy escape? They're both being divided by 5. That's not fair. So you're completely allowed to break it up. As long as both of these are being divided by 5, it's fine. And it's a good point. Sometimes the back of the book will show you one answer, and it's actually the same thing you got. It's just reorganized.
That's what my problem
That's a little bit evil, but they can't show every possible organization or else it'd be this thick of a book. So if you think you got a different answer, just run it by me. They might have reorganized it. Yeah. Any other questions? Yeah.
Yeah, number 45.
Oh, 45, yeah. It's come up a few times here. Oh yeah, 45 is free. So 45 looks like this. So they want to solve for L. Yeah, you could distribute. And that's a perfectly valid way to go. So I could do that. I'll see if anybody else says something different.
Divide, or multiply them all by 4.
You could multiply everything by 4. That's not a bad idea. In fact, I like that a little bit better. But either way it would work. You could distribute the negative 1/4, and you should be able to handle that. But one thing we're definitely allowed to do is to multiply by 4. Now here's where it's going to get interesting. Let me see if you guys are cool with this. Let me show you a little side note. There's a lot of little places where it seems like... Well, let me see what you think about this. If I had 2 plus 3, right? That's 5. You with me? Now, if I wanted to double that, that's got to go to both of these, right?
Mm-hmm.
Is that cool? All right, so that would be 4 plus 6, that's 10, that's double 5, that's cool. Everything's good. If I had 2 plus 2 times 3, well, that's 2 plus 6. You with me? Is that cool? I know this is a little weird, but I'm just playing with numbers here. This is part of what we have to do to understand algebra. Algebra is a bunch of things I don't know yet, so I better understand numbers. If I want to double this, if I do this, can you tell me what I did wrong?
You did not switch too much. We just made the 2.
What happened? What's my...
Addition.
2 times 2 is 4, and then I did something here. Exactly. I have to kind of do this first. And the real thing I did wrong is I've only got 1, 2 here. How did I double 2 and 3? This should be like 4 times 3. What I'm really asking you is if I said, and let's see if this is right, 4 plus 12 is 16, which is twice 8. So that works. So what I'm really saying is, how do you do 2 times 3 times 4? Is that 6 times 8? No. What did I do wrong? I doubled both of these. I only have 1, 2. How does it become on both of these things? It doesn't make any sense. So, Jeff, what the hell? I can hear your thoughts. Does it have to do with this? Well, how do I kill that fraction? Multiply by 4. Multiply this by 4, this by 4, and this thing by 4. So 4t is 4t. 4 times 27. Yep. 108. Yep. Minus, now 4 times 1/4 cancels, so I just left with W minus L. So pretty cool with that. Yes?
When you're distributing the 4 to the equated 1/4 times WL, how do you know, is it just because you know that the 1/4 is being multiplied times that, and that's where you know it right there at that point?
And that's how I know what now?
Where to put your 4 that you distribute to everybody?
Gotcha. Each piece has got to get a 4.
Yes.
So this piece, and this piece has to get a 4. Right? My point of all that was to make sure you didn't think I had to multiply this part another 4.
Oh, that's what I was.
That 4 I had died. There is no 4 left for this guy, is there? It's just like this. 2 times 3 times 4 should be 6 times 4. There's no 2 for this guy, 2. I've used it already. So that 4, I used it.
Is it because there's not an addition or something between the...
Exactly. There's no distribution there. It's all multiplication. And I multiply as it comes, straight. I don't distribute across multiplication. Otherwise, that would be 6 times 8, which would be crazy. Okay, hopeful.
But you did the parentheses around the 1/4 all the way to around the L? Or was it supposed to just go around the fraction?
Both would be the same thing.
Because it's one term.
They both would be the same thing because it's this times this times this.
Oh, okay.
So it would be the same thing. Yeah.
Because otherwise we'd be taking the multiplication away in between the 1/4 and the W, so like a whole function would disappear without it being used.
Well, I mean, she just said I could write this like this also. But I wanted to make sure you guys understood I am multiplying this whole thing by 4. It's just that when I do this, it's gone. I multiplied by 4 already. Also, I had 1/4 of W minus L. So if I multiply that by 4, I get a whole W minus L now. Right? Okay, so that's the weird thing about fractions, is to be careful when they're coefficients. If I do like John said, and the only reason I didn't want to do that is just to show you. But it's a little bit easier to see that maybe. But there's a couple things you got to be careful about. So John said earlier, why don't we just distribute that? So what's negative 1/4 times W? Yeah, negative 1/4 times negative is plus. Now if I multiply by 4, each piece has to get a 4. So then I get 4t equals 108 minus W plus L. So I still get, because here I'm going to get a minus W plus L there, once I get that negative through. Okay, maybe. A few different ways to do that problem. Now what's my whole motivation here? What am I trying to solve for? I'm trying to solve for that L, and currently it is stuck inside this parentheses, right? So I'm trying to free it up, and the most direct way to do that is to multiply by the stupid thing it's divided by. That'll free it up. So now if I bring that negative through, that variable I'm trying to solve for is now free. I can get him by himself now. I'm not allowed to break in here and take him out. I got to get rid of this guy first. Right? Guard at the door. I got to knock him out. Now he can come out. So what do I need to get rid of to get L by itself? Yeah, the L is with these things here, right? So I want to add W in.
Subtract 108.
There you go. So it'll be minus 108 plus W. So it'll be 4t minus 108 plus W equals L.
You just
Gross.
did that. You just did like 2 sets of 1, right? That's
I
it?
did.
Like you didn't
I did.
just like, okay, that looks like not
I
what you
did.
knew would. Okay, I just
I'm going to start to do that a little bit more
You would've
often.
just done it
I'm going to
next
start
one.
to do that more often because I don't like to write a lot.
Yeah, no, I like it.
And because you should be able to start handling that. Yeah. Yeah.
It doesn't matter if you write a negative 108 plus 4c plus w, right?
Doesn't matter. As long as that's negative, that's positive, and that's positive. You can write it whatever order you want. Yeah.
So if W and L are arbitrary and you had the quarter which you accounted for by multiplying by 4, and because you increased the term and the result by 4, it accounts for the 4 and the W and the L?
It kills that over 4, yeah. I think that's what you're asking. Let me show it to you one more way, just to really beat this thing to death here. Here's, I think, the clearest way to see this. All right, you guys ready? What's 1/4 times 3? What's a better way to write 1/4 times 3? We wouldn't write that. What would we write? 3/4, right? We put 3 over 4. So what's 1/4 times this guy over 4? Now is it a little more apparent that...
Oh, sorry, yeah.
Okay, good. All right. I got one convert. Let's see. If I multiply everything by 4 now, is it a little more apparent that that's gone? The one extra thing that's still, if you made a mistake on this, I could kind of let it go, because this is one of the most evil things. That minus sign has to go through still. But the next most common mistake is people will do this. And the mistake they made is they did minus W, but they didn't do minus negative L to make it plus L. And that floating minus is one of the most evil things man has created. Yes?
I did minus L on both sides, and then I divided by negative 1.
I like it.
That works. Same thing.
So you got the 4t over, and then minus L, and then divided by negative 1. I love it. Because then all your signs change back to this. Cool. There's a lot. There's like just about 87 billion different variations on this. So if you came out to here, you're most likely okay. But sometimes you have that old 2 wrong somehow make it right. So you got to be careful. But that sounds fine. And just to make you guys feel a little bit better, that is not the standard problem in this section, right? There was like one problem that looked like that. That one. So that's not the standard I'm going to expect. That's a little bit, that's kind of like, okay, you did all these, now try this one. Okay. All right, anything else before we... Yeah.
Number 63 on page 91.
Page 91?
Yeah, number 63. It's kind of like that same thing for the minus.
Oh, yeah. So this one is at least not involved in any division or anything. It's one of the lesser horrific floating minuses. Because what do I definitely have to do on this side? Because there's parentheses and there's a number out front that's not 1. So I have to distribute that to... Over here, the same thing. It's got parentheses. The number out front is -1. So I still have to distribute. And then what happens? Yeah, minus t. Minus 2. Yeah, it just changes both the signs in there, right? Negative times t is negative t. Negative times 2 is -2. And now you just do like terms on both sides. The nice thing on that side is the t's go away. Over here I get 6t minus 3, good. start to see how almost every equation has the same feel to it. Distribute, clean up, get your t's and numbers on the right sides, right? Who's in the wrong place? So I still did 3 in the wrong place here. 1, and then the last step is almost always divide. Yeah.
What about 49 this section? Instead of 13?
Oh, good. All right. There's this kind of problem, and then I'll do another one on the heels of this, and then we'll get into some new stuff. This is one of those really simple problems that suddenly turn into a monster, depending on which way you decide to go. So if you decide to subtract 3 first, that's where people get a little confused. If you subtract 3 first, you get here. And then it's kind of like, what the hell? We want to divide by 2 now or something. And it's not right, because let me see what I said. Are our x's together? No, they're not together yet. So we had that one like this the other day. I got my numbers together by making them cancel on one side. They happen to cancel on both. How do I get my x's together? Subtract 2x. Now actually, here's the other problem I want to show you. This led into it. Here people freak out and say the answer is undefined or something. Yeah. Don't let this 0 tell you what to do. This tells us what to do. Why is the x not by itself yet? The 4, so I divide by 4. I don't care there's a 0 over there. That has nothing to do with my next step. My next step is get rid of the damn 4. Right? So I don't care. Now on the next step, I'm going to care about what's over there. What's 0 divided by anything? 0. In fact, what's the only way that 6 times something is twice that thing if that thing is 0? That's the only way to do that, right? 6 times nothing is nothing, and twice nothing is nothing. That's the only way to do that. Think about it. I can't possibly multiply something by 6 and have it come out the same as if I just doubled it. Unless I started with nothing. Cool. Yeah, that's why that answer makes sense. Cool. All right. So let's get into some new stuff. And actually, before I get into brand new stuff, let me see if they do something. Yes, they do. Solve for m. So what is freaky about trying to solve this one for m? There's 2 m's. And now I'm going to blow your mind and say, no, there's not 2 m's. You're all going to say, well, I got to go, Jeff. You're obviously off your meds. There's 2 m's. But I can take them out. And there's 1 m. What's left inside? Yeah, there must have been an A that distributed to, and there must have been a B that distributed to. So that's that really simple factoring, what I call undistribute. So whenever you have more than one letter you're trying to solve for, get them all on one side and pull them out. Then there's only one of them. How do I solve for m now? What do I want to get rid of? The A minus B, and what's the m doing to it? So then I'm going to divide. I don't want to distribute because then I'll be right back where I was. So divide by the stuff I'm multiplying by that I don't want. And there you go. If I were to add the b over and divide by a, you'd have m equals something, but then m would be on both sides. That's not solved for m. You don't have m by itself. You have it on both sides. That sucks. This is what you do. Every time you have more than one letter you're trying to solve for, this is what you do. Because there really isn't more than one. You just have to suck it out to see it. Okay. All right. So I'm going to do a little bit out of order just because 2.4 and 2.5 are normally two of our most look forward to things. Section 2.4 is involving applications with percent, and section 2.5 is the pure word problems. So let's do 2.6 first, because we're coming right off of solving equations, and 2.6 is solving inequalities, and they're really almost exactly the same steps. There's always, at least in my mind, a method to my madness. So 2.6 involves inequalities. And let me start with the real basics. Can you graph that? Okay, so do it. Take a second and do it.
You go to -1 and then you shade everything to the left.
Stop. So you have to forgive me because I'm teaching on a 103 also, and we've been doing a lot of review, so we're basically talking about almost the same thing. So I always forget what I've already done. I can't remember if we've done any of this yet, this inequality stuff. Okay, good. What are you guys used to putting here?
A dot.
Not just a dot. It's got to be a little more specific because I'm not allowed. See, it's got to be less than -1. It can't equal -1, right? So we're used to using either like an open circle or a shaded in circle. Does that sound familiar to most of you guys? Not the open. The difference is, we definitely can all agree on one thing. What am I going to do here? Shade. So it kind of makes sense that shading indicates answers, right? Is this so far so good? So what does this actually say? It says the answers are less than -1. So to show that visually, I'm going to shade in where the answers are. So if they're less than -1, the really cool thing is if your variable is here, your inequality symbol points you in the direction to shade. So it's pointing down, I shade down. Now the thing here is, if I don't want to include -1, I don't want to shade it, because shading means answer. That's why in the past, we would have put an open circle there. That means don't include this.
It means it can't be -1.
If this says it's got to be less than -1, is -1 less than -1? No. But is -2 less than -1?
Yes.
Yes. And -3 is less than -1? Is 0 less than -1? No, and that's why it's not shaded. And -1 is not less than -1, so it's not shaded either.
So you don't want to choose the open circle?
I'll get to that. I want to make sure everybody's kind of with me, and then I'll show you what symbols we're going to use now. And don't worry, you don't change every class you go to. I'm changing you to the correct symbol to use, period. You with me? If you're not suddenly 103, they're going to say, now we use stars. No. So the only difference between that and this, I still want to shade down from that, but now I want to include this so the circle itself has to be shaded. That's the whole point behind what used to be the open circle and the closed circle. Right? If your teacher didn't get into that, I'm a little worried about them. But that's all right.
Like, when you said graphing, I'm thinking like this thing,
No.
like line, that's
No.
the only graphing I have.
Shading in answers for inequalities, yeah. Cool. Okay. So we got the open circle means you don't want to include it, but the shading is all the answers. And the really nice shortcut is, if the variable is on this side, the sign points you in the direction you want to shade. It does not happen very often in math, so like it when it does.
Oh, no, I was just going to say the symbol.
Okay.
One more time, you said if whichever way it's pointing.
That's the way you shade. As long as your variable's there. If my variable was on the other side, if x is less than -1, then -1 is bigger than x, and you see now it's pointing the wrong way. You guys with me? So if your variable is on this side, that points you in the direction you're going to shade. That's a nice shortcut. So, now that I got through telling you what symbols you should have been using before, the symbols we're going to use now and forevermore. The open circle will now be parentheses. So basically it's like half of an open circle. Some of you guys maybe know where I'm going with this. There's something called interval notation. We're heading in that direction. Some of you guys are like, whatever you just said, dude. Just get to it. So open circle, you basically just cut in half from what you were used to. You just make it a parenthesis. Closed circle means that I want to include it, right? If it's less than or equal to negative 1, I want to include that. You with me? So then I take the letter I and I just take a few off and I use a bracket. So bracket means include because it looks like part of an I. Parenthesis means don't include because it looks like part of an open circle. I'm just trying to get that stuck in your brain. So how should I really do this then? Like that. And how should I do this?
Bracket.
Like that. You see how it's open in the direction it's going to shade like that? Do you see that? Let's do a couple more basic ones, and then we'll start doing some we got to solve. And then we'll talk about interval notation. I don't want to talk about that yet. So how about this one here? Go ahead and graph that. Another way to think about it, remember way back when I said graph this on a number line, what did you guys, you have 10, 11, 12, so then you put a dot there, right? The minute I say greater than or equal to 11, I really want you to put a dot on everything that works. I want you to put a dot on everything. Well, what works? 11, 11.0001, 11.0002, 11.002, oh shit. So I'm just going to shade the damn thing. It's going to take forever. Screw it. That's really all I'm doing is putting dots on all the answers. And then right on 11, what symbol am I going to have? Bracket. I want to include it, so I want the one that looks like an I. And shade up from there. Coolness.
So when you do the bracket, that means you replace the dot by the bracket?
Yeah, you're not going to have a closed circle now. You're going to have a bracket. I like it. Closed circle meant include, now bracket. Means the same thing. It means
So we don't have
include.
to worry about that one now, just this one. Not worry about
The circle, no more. Yeah.
Is it parentheses open towards direction?
Exactly, they both do. So if I had x greater than 10, this would be 10. On the 10, I would have a parenthesis because it's not allowed to equal. It's got to be like an open circle and then a shade up. See how it points in the direction? It's like a satellite dish, right? Is that cool? If I would have been shading down, it would have opened that way. If that's the only mistake you make of a problem, though, I'm not going to cry. But it kind of helps me, it kind of contains it this way. So if it's this way, it wants to contain it the other way. Yeah?
When did the circles go away?
Just now. Weren't you here? The reason, and I might as well get into this, the reason that the circles go away is to make it a little more true to a format that we use very often, and it's called interval notation. So the way to do interval notation, for example, on this guy, interval notation goes, you say, from the smallest up to the biggest answer possible, right? Well, the biggest answer possible here was -1, right? Everything else, all the other answers are below that. So up to -1, and you just use the same exact symbol from the picture. Now you see why we want to do that. You just copy the same exact symbol. Where did I start at, though? I love it. Negative infinity, right? From way the hell down there. And you always use a parenthesis on infinities. And here's why. I can include -1 because I can get there, right? I've certainly owed $1 to somebody, so I've existed in that place. The minute you reach infinity, you can use a bracket there. Let me know if you do. That's neat. So you always use parentheses on infinities because you can never include them. Infinity is itself something you can never catch. It's always one step away from you, no matter how close you think you got. You kind of with me? A little bit, okay. It's like nirvana. Here's infinity, poof, you disappear. You become pure energy or something, I don't know. So let me know if that happens to you. I always have somebody do this. Please don't do that. Don't write it down. Why is that not good?
Because it can't be.
Because then what the hell's that? Here's the end of the world. Well, here I am. So, never put infinities on your number line. That doesn't make any sense. And that's really the same reason I can never include it, because I can never find it here. How you guys doing? That shading means infinity. It just never stops. There's no floor. So, how would this one look? Interval notation. What's the smallest? 11. What's the biggest? So there's always a parenthesis there, and here I just put the same symbol I put there. And this one, how would that look? The biggest is
10.
infinity, the smallest is 10, and on the 10 I put parentheses. So when I see this, I know this means I'm allowed to use any number from 10 up, not including 10. That's the quickest way to tell somebody all the numbers that work or all the numbers I'm allowed to use, whatever the situation is. It's quicker than making this number line picture. It's very direct and to the point, and that's what we use most often in mathematics, to indicate all the numbers in between this and this. So what about this here then? Before we get into solving inequalities.
So divide this 7.
No, I don't have to do a damn thing here, right? Is the x by itself?
Mm-hmm.
Yes, it's in the middle there, right? What's a good, I love it. That's exactly the best way to say this. All the answers are between 7 and 21. And this is very true to life. Right? I mean, there's a certain minimum amount of stuff I can sell just to keep my business open, but there's a certain maximum enough stuff I can make. So I live in between these two extremes. I mean, real life is really all about extremes very often.
So you shaded between 7 and 21?
Exactly. So on a number line, this is almost easier than those. It's kind of nice when they're, I call it sandwiched. They're sandwiched in there. You got your 7, you have a bunch of crap, and they got 21. What goes on the 7? Parentheses. And what goes on the 21? Bracket. Because that's included and that is not. It is shaded in the middle. Notice that people sometimes wonder, why didn't I shade down from here, Jeff? Because this says 7 less than x, therefore x is bigger than 7 if I read it that way, right? The x is kind of like on the wrong side there. So it's x is bigger than 7, but it's also smaller than 21, so it's sandwiched in the middle. Okay, maybe. Yes, sir.
So, like you just said, in that one, the best thing to do would be to read it from the middle out.
Exactly. Like x is between 7 and 21. Including 21, not including 7. Yeah. Cool. How would this look? Oh, sorry.
Then you would write it in parentheses 7.
I know. Now this is why the next step is still easy. What's the smallest thing? And what goes on it? Yeah. Biggest thing? 21, what goes on it? So that kind of translates directly into interval notation. So the sandwich dude is the one that people think is going to be the hardest, but actually ends up being the easier one. Okay. Yes, sir.
So if it's 7, is it not possible for 7 to be greater than or
Yeah, x can never be 7, right? Because 7 is not less than 7. Or it could be 7.0002. Yeah. That's all right. Don't do that. That's my job. No. Cool. All right.
Yeah, I got it.
So let's try this. Let's try some solving of these things. I think I said this earlier. Shannon, you good? I think I said this earlier about the only thing you have to worry about when you're solving inequalities is when you divide or multiply by a negative. and I showed you this example, because there was a question that kind of brought me there a little earlier. Which one of these is bigger? 2. But when I divide or multiply by -1, this becomes -2, that becomes 1. Now the 1 is bigger, the sign flipped. So you solve an inequality the exact same way you solved an equation. Whatever you do to one side, you do to all sides. There's a reason I said it that way. But the minute you divide or multiply by -1, the sign's got to flip. Now, if an equal sign flipped, would we know? So I could say it's been happening the whole damn time. Because if you flip that, whoop, there it looks the same. So let's try a problem out here together, and then I'll give you one to try on your own. All right, so what's the first step? Yeah, good. So it's just like solving an equation. Distribute. And then? Or somebody pointed out, I mean, these two cancel. It's kind of nice to notice, but, or else you just go ahead and combine like terms. And now I'm at the point where I got letters, numbers, I just pick which way to go with them, right? So who do I want to do what to where? Yeah, do what with this? Subtract it over. So it's just like solving an equation. Just like solving an equation, yes?
We talked about this the other day, but why can't you just jump from the 2x minus 6 to the 2x minus 4, knowing right there that you're able to distribute those properly all the way down, and just leave it at 2.
So if you subtract 2x and add 6 right now, that's fine. That's exactly what you're saying to do.
Yes, because I see it in...
I love it. Not a damn thing wrong with that. That's exactly like the dude that said the other day, if you see the same thing on both sides, they cancel. Right? I can subtract 2x and they would cancel. You just go one step further and you say, let me just add the 6. Will it always work like that? No. You won't always be able to see that kind of thing. But if you see it, that's perfect. Anytime you add the same thing or subtract the same thing from both sides, that's completely legal.
So when you see me do it, you can do it.
You certainly can. This is the first time I've really heard somebody say they see it like that, but it's beautiful. Everybody's different. We all see things differently. This is why we need more people that understand math so you can bring more perspective in. I'm going to show you the most by-the-book method normally, right? And I'm going to every now and again point out different things you can do, but it depends on how comfortable you feel and what you see. So anytime I do a problem, there is probably at least 28 different ways people are thinking about doing it that are valid. And maybe about 5 that aren't, so you gotta be careful. But there's definitely more than one way to do this. Now here, the last step, add 6. Cool. And now I can ask you, graph this, give me the interval notation, right? So how would you graph this thing? 2 in there. Good, bracket, and I'm going to shade. Oh. Good. I have a problem with left and right. That's left because it makes an L, so I have to do that. Somebody's giving me directions in the car, I do that. Give me a break, I got too much other shit in my head. How do I make this in an interval notation? Yeah, bracket from 2 to infinity, because there's no ceiling on this thing, right? It just keeps going. Parenthesis, because you can't get there. All right, so let me give you guys one to try on your own. Actually being kind of nice.
So just so I understand what he was asking earlier, he was talking about skipping some steps, like
not writing it down, going from 2x minus 6 plus x greater than or equal to 2x minus 4, and then just skips right down to like negative 2 plus x, and you get everything on the other side, so you have to add 2.
Wait, I'm sorry. Are you talking about what Kurt was talking about? So what about this one? Sorry?
You go from the second step, and you notice how the 2x and 2x cancel out.
Yes, good.
And then the negative 6 and negative 4 cancels out, so then you're left with negative 2 plus x and nothing on the other side, so you just have to add 2.
I like it. That's fine.
Okay.
I would never teach that. I would never teach that because you happen to see that, and that's beautiful. I'm always going to teach the purely by the book method and maybe change it just a little bit, and show different ways to do it, but I'm never going to, that works. I know exactly what you're saying.
Right.
There might be some other people that are like, I don't know what the hell he just said, just stop saying something else. Right? So that's perfect. I understand what you're saying. It's beautiful. And it's sort of the same way I think Kurt was saying.
Yeah. I was
So-
trying to understand what you were asking.
Cool. So it's just a little evil in this one, actually. If you get a fractional answer in here, you just have to roughly locate it on number line. It's not a big deal. Should not be a big deal. Oh, so that's what the open circle used to be. It's don't include. That'd be for a symbol like that. Right? This means include if it's allowed to equal. I would use that. And real quick, I've seen people have told me, I always forget, but when you see that line in there, it means equal. You use the symbol that has a line on it. Whatever keeps it in your head. Or not, if it doesn't help. So what happens here? What do I do first? Distribute. Plus 4x, good. So now you combine like terms. 7x minus 8, less than 6 minus 2x. And now here's where you just start moving the x's in the numbers. Add 2x. Get 9x minus 8, less than 6. Add 8. 9x less than 14. Divide by 9. X less than 14 ninths. What is 14 ninths as a mixed number? Can't reduce it, but you can write it as 1 and 5 ninths. Right? So I know it's going to be in between 1 and 2. So when I go to graph it, that's all I got to do. Just put something in between 1 and 2. Then that could be perfect. How are we doing? Is that all right? So obviously, if you have any trouble solving equations, you will have trouble solving inequalities. It's the same exact steps. The only thing is, if you have a negative, we got to be careful. So we'll see that in a minute. So if we want to graph this thing, I know that this is in between 1 and 2. Which way am I going to shade? Down. And what symbol do I want to use? Parentheses. So I'll just kind of do like that. Put your 1 and 5 lines there.
How would you write
Interval notation?
Yes.
What's the lowest thing?
1
No. 1 and 5 ninths is the biggest thing. So when I go from negative infinity, as I start way down there, negative infinity, and then I come up here and I stop right there. That's the ceiling. The floor is not there. I just keep going down. Bottomless well. Dante's Inferno. I don't know. Up here, the highest one is 1 and 5 ninths, and I use the same symbol I already used. So from smallest up to biggest. Don't get those turned around because that doesn't make any sense. Smallest to biggest. How's that? Is that all right? Okay. So let's do two different types here. Let's do a negative problem, see what happens, and let's do a sandwich problem. Very quickly, if I had something like this here. I'm going to do this two different ways to show you why this really happens. And we already know why it happens. It happens because it happens. I love that answer. Because the whole thing with the 2 and the negative 1, I've already done it twice. I'm not going to do it again. Right? It's got to switch when I multiply or divide by negative. But I want to show you even another reason why. So let's solve this thing together. Of course, I have to first distribute. That sucks. Let's just stay with it. 6 minus 2x plus 8. So there's a place where you could do that. Those go away, right? But just sticking by the book, I'll get 14 minus 2x. Six plus 8, right? And then I can subtract 14, good. That goes away. I get negative 2x less than or equal to negative 6. Is everybody good so far? And again, there's a lot of little offshoots of ways to get there and so forth, but we're all going to get to the same place. And the last thing I want to do is divide by negative 2, which means I have to flip that sign. Easiest damn thing in the world to forget.
It's only when you divide or multiply?
I like it. By a negative. It's only when you divide or multiply by a negative. Cool? Not when you have a negative somewhere in your problem, but when we divided by negative 2. I flip it. If I would have divided by positive 2, I would leave that alone, even though there's a negative 6 in there. It depends on what I do. Again, here's one reason why. 2 is bigger. When I divide by negative 1, now suddenly 1's bigger. Sign switched. Now here's another way to look at it if that's not satisfying enough. From this point right here, let's say right here, I could have done things differently. I want my variable positive, so I could add 2x. Go with me. So I can add 2x. Then subtract 8. Then divide by 2. Well, what does that say? 3 is less than or equal to x, which means x is bigger than or equal to 3. So to make it valid, if I don't take the x to the other side of the sign, I've got to turn the damn sign around to make it the same. There's a whole other reason why it switches, yeah.
Why are you using the term valid? Isn't that what that says?
To make my steps valid. Right, so everything I've done up here is currently valid, and I'm explaining why doing this makes it valid. Why must I switch the sign here? I showed one reason why, but if that's not enough, here's another reason why. To be valid, I can't do something 2 different ways and get 2 different answers. Math says, okay, there's a lot of different ways, but you better freaking come out to the same thing.
So why can't, what's wrong with doing it this way?
Not a damn thing. So if you always want to do it this way.
So you can't remember
I love it. So you can always keep your variable positive, just at the end you just got to remember to flip it. Right, mirror image this thing, so then you turn the whole thing around. And that's just to make sure you end up shading the right way, right? You guys with me? Not a damn thing wrong with this, but at the same time I need you to understand this requirement. But you never have to do this really, like you just said. There's a way out of it. If you make your x's always positive, you never have to worry about this.
Did you say when you multiply?
I got some people... Oh, really? I like it. I'm a little concerned when I say that, but it's the truth. I don't want you to forget that you'd have to do this, but you certainly have a way out of it. Now, if I had a problem like this, it's a long way to go the other way. Add x and subtract x. So I would hope to God we'd all be cool with just doing that. Flip the sign because I divided by a negative 1. You with me? There's some problems where going the other way is just kind of crazy. It doubles my workload. Why the hell would I do that? We should be able to do this. But that's nice to know that I don't have to do that. I can always make my variables positive, right? Yes, ma'am.
Doesn't that say the exact same thing though, even though you switched it?
I love it.
Like the exact same thing?
Yes. That's the whole point. I can't possibly say my answer is two conflicting statements. So this is the same as this. So I've just rewritten my answer.
You were proving a point on that one.
Exactly.
Oh, that's not the right way to do it.
This is perfectly valid. This makes more sense to us.
Oh, okay.
Yeah. Good. Yeah.
Why does that sign switch on that one? Because there's no negatives.
I didn't switch the sign. If 3 is less than x, listen, if 3 is less than x, that's what that says, right? Then x has to be bigger than 3.
Oh, you just switched to 3.
Mirror image, right? The mirror theorem. We'll make a name of it. Yeah.
Did you say that also when you multiply by a negative, you switch the sign?
Yeah, multiply or divide by negative. Cool. And again, it's really just because when I multiply or divide by negative, I change the side of the number line I'm on. Now the bigger one is smaller, smaller one is bigger. It's that simple. And what's x besides a number that I don't know? So it better act like any other number would. Every damn thing I can do with numbers, I have to be able to do with x's because they are just numbers. Hopeful. That is definitely the category of easiest thing to forget, right? To switch that damn sign. But hopefully I've got it in your brain enough that it has to happen. Now some of you guys are going to do it too often, but oh. All right. So any questions on that? Yes,
And then
yes, sir.
just to graph that, it's at the 3 with brackets going to the right.
I like it. So now to graph this thing, I definitely want to use that bracket, and I want to shade up. And then interval notation from 3 to infinity, and then you just put the appropriate symbols on. Infinity always has parentheses. I use a bracket there because I use a bracket there. Coolness. And again, this is really just because this is nice for us, a nice visual, but this is what we use most often in mathematics. So we got to start getting used to this. Especially if any of you guys ever end up in pre-calculus possibly. I know a few of you guys have to go at least that far. This is going to be everywhere in response to all kinds of questions. You want to say, what x is going to use from here to here? What output's going to see from here to here? I'm going to be using interval notation a lot because I don't want to graph a bunch of little number lines. Yeah.
Is there a function of operation for that interval notation that you used just now? Because I see that you're using the bracket on the left side instead of on the right, and then the
Well, it's really
continuation on the left.
the 3 is the important number here, and I want to include the 3. So whatever symbol I have on the 3, I have it on the 3 in this notation. So that's
from
just
your known or from your given point of reference.
yeah. From here, I have a bracket on 3, so I better have a bracket on 3. Interval.
And the reason I asked that is because your example that you give here, x is greater than or equal to 3. And then I look back over at the other one and it says 3 is less than or equal to x.
I love it, and they do exactly the same thing.
So I'm going.
Be careful.
That's why I've always
Understood. But if 3 is smaller than x, x has to be numbers like 4, 5, 6. So it would still lead me in that direction. It's just that we don't look at this and immediately think that way. That's why I said we need to turn it around so it's more of what we're used to.
But when I write a notation, there you go.
Be careful. This would still lead me to this notation.
Yes.
Definitely. It's just not as easy to see as this is. And these both say the same thing. That's why I would want it in this form, right? Because it's easier to see in this form. When the variable is on this side, it's all easier to see. Because then the symbol greater than, I expect to go up. When I see the symbol less than, I think going down, that's wrong. Because my numbers have to be bigger than 3. Let me turn it around so I can see that. Okay. Okay. So what about sandwich? Is that John? John, you were asking for it, man. All right. So if I have something like let's make this not too evil. So here is a sandwich problem. Yeah, so sandwich, a really good sandwich is known as a sandwich, if you didn't know this. So this, I call it a sandwich because it's got a definite inside, it's got pieces of bread on the outside, so just work with it, right? When you graph it, it's sandwiching things in the middle. Okay, if you don't like the idea of sandwich, or if you're just hungry because you didn't have lunch, I'm sorry. Stop using that word. So here's the thing, if that wasn't there, none of us would be freaking out, really. We'd be able to handle that. So that being there shouldn't change a damn thing, because whatever I do to one side, I do to all sides. So what I want to do first. Yeah, so what tells me what to do is here, because my x is not by itself. These have nothing to do with what I do next. So here I want to get rid of the 6 so I can start getting the x by itself. And whatever I do to the inside, I better do to the left and right side. So what do you get here? Negative 8 less than, careful, negative 4x less than or equal to 4. Yeah, divide by negative 4. So you get 2. Good. Is greater than x is greater than or equal to negative 1. Why did I switch those signs? Because we divided by negative. And if I didn't switch the signs, it wouldn't make a damn bit of sense if I would have left it like this. Look what this is really saying. This is saying 2 is less than negative 1. Okay, that's freaking me out. This is saying 2 is bigger than negative 1. Okay, that makes more sense. So this is kind of the same problem as this, really. If my signs are kind of like in the wrong direction, the bigger one is here and the smaller one is, then we just turn the whole damn thing around. Negative 1 less than x less than 2. Now, I just mirror image the whole thing. Now it's a little bit better. Smaller here, bigger there. I'm more used to that. You guys with me? Do you have to do that? No. Do I recommend doing that? Yeah. Maybe you're with me. Maybe you just want it all to be over. Okay. So now how do I graph this? Good. Negative 1 bracket. And then 2 parentheses. And then just shade the sandwich. Put the jelly in the sandwich. Yes?
You said you were going to have a negative left to right, you said? Could you have a negative?
Right here, everything's kind of reversed because I have my bigger one on this side and my smaller one on that side. So my suggestion is to turn the whole damn thing around. So now I go small up to big. Then it can go right to my picture better. When people leave it like that, they end up having everything in the wrong place. But I should have a small one here and my big one over there. That makes more sense. And of course, interval notation would just be bracket, negative 1, up to 2. Bam. So the sandwich is nice. It goes right into interval notation directly. Yes, ma'am.
The first one is not a multiple.
This isn't wrong. It's just the same the way that this isn't wrong. It just leads to incorrect next steps very often because we interpret this incorrectly. So it's better to kind of switch things around. This is in the wrong order just because it's the big one there and the small one there. We're used to it actually being the other way around. Okay. Go forward. Yes, sir.
So are you saying that 2 greater than x greater than or equal to negative 1 is the same as the bottom location?
Definitely.
You're just
yeah, because 2 is definitely bigger than the answers.
Right.
Which is definitely bigger than negative 1, yeah.
So my question in the end is, will you take either answer?
Hell yes. Okay. So remember, it was just a strong suggestion. Okay. It wasn't a requirement.
Okay.
Yeah. You can still do this and still be okay, but very often I'll get people put the 2 there and the negative 1 there, and then I'm like, whoa, wait a minute.
I see.
Cool. So I'm just trying to keep that from happening. Okay. Yes, sir.
So in the sandwich kind of problem, it looks like you shade the opposite way there.
No. So this piece is backwards, remember? So what's this really say? X is bigger than, if I look at it that way, so it's bigger than -1 and it's less than 2. That's why it ends up being in the middle. Because that piece is backwards, but it has to be so I can write it in the middle. Does that make sense? So that's why it's much better to think about the answers are between this and this.
Right.
And just start from there instead of going, oh, I'm shaded the wrong way. No, you're actually fine. It's just backwards. Just between there and there. Bam. Let's take a break. You guys are making me tired. Let's come back. 5 till. 5 till.
Homework, like all that we do, you kind of all be stapled together in one bundle, or do you want it separate?
That's fine. Staple together is fine. Cool. No, because we haven't made it to the end of this yet. These are the dates that I'm going to be in here. The due dates are always 2 class periods after I'm done with something. And then the hard due date is the day of the test. That's when, if you turn it after, that's going to be late. Yeah, you have until then to turn in the homework, but please try and turn it in before then. Yeah.
I have a question.
Yeah.
So, all that stuff is due
At the latest, yeah.
Okay, but
Cool. You can turn it in before then, please.
all of them. This is the
Certain.
I have some.
Yeah, as you get it done, you turn it in. Because then I can give it back to you. Graded, yeah. Yeah, thank you. Oh,
And the first one that you just get, I would have to correct and give it back to you. Okay.
oh, if I say correct, then you just make the corrections to the ones that were wrong and give it back to me. Yeah.
Did you already take it home?
Say again?
Did you take it over?
I don't take it.
Oh, okay.
Yeah.
Well,
Basically, the quiz was rolled.
Oh, okay.
Yeah.
Well, I got your email like at 1:45, right? On camp, I came to campus at 1:45 because I got yesterday's email.
Oh, I see. All right. Okay. What's your name?
Torres.
All right. And you, did you
They
take?
didn't drop me anything on your roster.
Who would drop you?
Remember that I had that issue with financial aid that they were going to drop.
Oh, I didn't look.
Okay. Because my record
Have you
says
looked?
that I'm still on.
Yeah, you're good then.
Okay.
Yeah, mine would say the same thing yours does.
Okay.
Yeah.
I have a question. What I'm confused about is when do I use the bracket and the parentheses on the number line?
So here it's greater than or equal to. So I want to include 3 as an answer. It can equal 3. That's a bracket. If it would have been just greater than, I would use parentheses. Because that means then 3 is not bigger than 3. I don't want to include 3.
So when it's greater than or equal to, then I would use the bracket?
Or less than or equal to. If it has an equal to sign, use the
Okay.
bracket.
Okay.
And again, some people like this. When it has this hard line, use the one with the hard line.
Okay.
When it doesn't have the hard line, use the one that doesn't have a hard line.
Okay.
Yeah.
All right, thank you.
Sure. For what? Homework? Day of the final exam. You got some time. I'd rather, okay, but I'd rather you keep up with the current homework. That's the priority, and if you have time, you do your corrections. Cool. If I could tell what happened and what's new, that's cool, or another sheet of paper. Yeah, but some people are able to put it on there in a different color or something. Just don't change any of the original. Yeah.
Do you have the new homework?
I do.
Or is this, do we keep this one? Our old one?
Sure.
Okay.
But I'll give you the new one here in a bit.
Okay.
So I did the work for 2, but I'm missing the rest, which is 2.3 and then the 3.3.
2.3?
Yeah, to the section.
Okay.
So when I finish it, I'll bring it and take a look to this one, or
Cool.
do you want me to?
No, you can just turn it in separate.
Oh.
Yeah.